The work energy theorem states that if the energy in a system changes, it's because a force did work on the system. In this example problem, we want to look at how the force of friction can affect the energy that's present within a system. We've got a block that's set up on a ramp, and this is going to be a frictionless ramp. Nice frictionless ramp, so the block will slide down, pick up speed, but the floor has a coefficient of friction of 0.35. So eventually the block is going to slow to a stop due to that friction. The friction will basically burn up all the kinetic energy, turn it into thermal energy, and just release that energy into the surroundings. It won't be with the block anymore. And so the question is, how far can the block slide until it comes to a stop? And that's a perfect problem to use the work energy theorem on. Now, to write the work energy theorem as an equation, we can just say that the work in joules equals the change in energy. And that would be work equals delta E. Well, the work is going to be the force of friction times the distance that the box slides while friction is working to slow the box down. And then the change in energy is something we can look at here. Now, technically, delta E would be E final minus E initial. Now, when the block hits the ground here, it'll have plenty of kinetic energy, but that kinetic energy just came from the potential that it had by being up high. So what we can say is that the initial energy is GPE, and that the final energy is 0, because all the energy was removed from the system. Now you might notice here we're going to wind up with some negative answers because of this. Technically, negative work is considered removing energy from a system, and positive work is adding energy to a system. In order to avoid confusion with this, it's an acceptable shortcut to say work equals delta E, and that the amount of energy is equivalent to the GPE, and that force times distance is the substitution for work. So while this is kind of going on behind the scenes, the negative sign can be confusing. We're going to just work on the right side of the page now to get our final answers. It's perfectly acceptable to say that the work is equal to the change of energy in the system, and all the energy that was in the system was the GPE. So this is going to be a lot simpler for people to look at here. Now, as we make further substitutions, we ultimately want to solve for the distance here. We know that the GPE is going to be mgh, and while we don't know the mass, we just said that the block has mass m, we know that the height is 4 meters. Friction is going to be equal to mu times the normal force, and since we've got a nice level floor here at the bottom, we know that the normal force is equivalent to the weight, and so mu times the normal force, that's our substitution there, and then bring down the distance. Now if we write it out this way, substituting mg for the normal force, we notice that mg appears on both sides of the equations and cancels out, so that the distance is going to equal 4 over mu, that's 4 over 0.35, and using a calculator to get this, we get a distance of 11.4, just to 2 sig figs, that'll be 11 meters. So the box will slide 11 meters while friction acts to slow the box down.